Hello, welcome to the tutorial for the Titan-3-3M CAM programming tutorial. We are going to start with copying the model. So you're going to open your data panel and right click on the Titan-3-3M model, select copy, and you're going to put it in your own project. It's important we do this, otherwise you're modifying the model that everybody else is in the class is working from. Okay, so in my case I have a demo project, and you should see it appear in your project. I'm going to double click that model to open it up, and we're going to switch to manufacturer mode to do our CAM programming. We're going to double check we're in inches, and as we have in the past, we're going to create a new setup. We're making a circular part, but it's going to start as a square part cut from the same bar stock we've been doing all the other projects from. So we're going to select stock, and we're going to set that up initially. So on our stock sides, our diameter that we're working with is, according to the drawing, 1.95, so that leaves us 0.025 on the sides. And our top offset, we'll just leave that at 40 at default. That's what we've been doing on everything else. And our bottom offset is the difference between 0.79 and 1 inch. So our bottom offset would be 0.21, and that's the material we're going to clamp on in our vise. Okay, we're going to go back to setup, and we're going to set our origin again on this same stock point, left back corner. Easy place to register for a first operation, and since it's a first operation, we are going off stock, and we select that. Now my axes happen to be in the correct orientation already, but if they're not, you'll have to go to this box here and select the Z-plane, X-axis, and then the point. Okay, now we're going to go to the post-process tab, and we're going to go with the same convention. We started with 1011, so we'll call this 1021 for this part, and our program comment will be operation 1 with a work coordinate system of 1. Then we'll select OK, and we're going to take a look at an approach on how we're going to make this part. So we have a bolt pattern. They're 1032 threaded holes with a slight lead-in chamfer, and then we have what looks like an O-ring feature, some sort of gland, and then there's a really thin wall here, and then a pocket in the center. So often you want to think about strategy on how you cut something that's a thin wall. Try to leave as much mass on it as possible until for the machining, so that you maintain rigidity. So what we're going to do is, I anticipate a fair amount of friction from our chamfer mill pushing on this edge, and we could bend that wall. So what we're going to do is, we're going to first machine the pocket, and then we'll chamfer the inside edge while this still has full thickness on it. And then after that chamfering is done on the inside edge, we'll do the outside edge, and then we'll spot the holes. And then the next operation, we'll come through and do all our drilling, and then we'll come back and do this this groove last. So that'll be our approach. Okay, there's more than one way to tackle these projects, but that's the approach we're going to take on this one. All right, so first we're going to go and we're going to do a face mill. We got to do a 2D face mill operation, and we're going to select our tool, which from the Titan library is going to be your tool 1. That's our 3-inch face mill. And again, we're going to go 4,000 RPM and 25 inches a minute. This is a small part. Even if we were going to run full tilt, using a 3-inch cutter to cut a 2-inch part by 2-inch part puts a lot of torque on that part. So we might go pretty conservative on this one anyway, even if you had a lot of experience. Okay, our stock contours are gonna, there's nothing to select, it's gonna default to our stock boundary we had. And then now we're gonna go to our heights. Clearance height default, retract height is stock top at default. Feed height is gonna be top height, 0.2 higher. Our top height is the stock, because that's where we're gonna start machining. And our bottom height is going to be model top, so we're going to be machining off in between the cyan and blue planes. So we pretty much leave this whole page at default. And we're going to the next page. 4/10 tolerance, pass direction, 0 is fine. Pass extension, we want a little over half the diameter of the cutter. And then we're not going to deal with stock offset, and we're going to leave the step over alone. We're going to allow the cutter to go both ways, and these other boxes all stay at default. I'm going to move on to the linking tab. On the linking tab, we're going to leave everything in the first box at default. We want a lead-in entry. I don't believe in vertical lead-in radiuses for a face mill, so we're going to set that at 0. And we're going to have a lead in and out the same, and smooth transition. I'll select OK. So we should have this starting off well off the stock and feeding in and feeding back out. All right, moving on. We're moving a little faster because you have some experience. All right, so now we're going to go in and we're going to mill out this pocket. According to our drawing, that pocket is 1 inch and 1/8 in diameter. For the most part, you want to try to get the largest cutter you can into a feature, unless it's really close to the diameter of the cutter itself. The end mill tip is not exactly flat, it has a slight taper on it, so it does have to do some horizontal movement in order to produce a flat. And if you come straight down, you get a very slight tapered cone. Go in there with a 1/2 inch. So it's a 2D pocket, and we're going to select tool number 2 from the Titan building blocks, which is our 1/2 inch flat end mill. 4,000 RPM, 25 inches a minute, 25 inches a minute on lead in, 25 inches a minute on lead out. Guess what? 13 on the others. Probably could just leave that number, it's close enough. We're going to go to geometry. We're going to select the bottom of our pocket. Leave the rest at default. We're going to go to our heights. Now again, we've already milled off the stock on the top, so we really want the top to be, retract to be at model top, and the top height at model top. And then I'm going to bump the offset up to 0.3. Because we're going to use a helical ramp in on this, so we need a little room for the helix to have a starting point. Okay, our top height is the model top, and the bottom is going to be the geometry we selected, which is there. We're going to move on to the next tab. For 4,000 tolerance, we want wear compensation, and compensation radius can stay the same. We're going to do finish passes. We're going to do one finish pass. We're going to leave 20 thousandths for the finish cut to remove. We're going to lead in on all finish cuts. 25 inches a minute. We're not going to repeat any of the finish passes, and most of these can be set at default. Our maximum step over, we're going to put 0.25 just so that we start out with a couple rough steps. And then we're moving on down to smoothing deviation, and then multiple depths. We are going to do one finish step at 10 thousandths. We're going to finish at final depth only. We are going to rough that final depth, and we're going to use even step downs. So I'm going to hide this for a moment. We're going to skip stock to leave, and now we're going to move over to the passes. We're going to leave all these boxes at the top on default. We got our horizontal lead-in radius, 0.05, that's fine. 90 thousandths angle. Linear lead-in distance is 5 thousandths. Vertical lead-in radius, we're going to set that at 0. We're going to leave these two at default selected. We're going to have a ramp, 2 degrees. Maximum ramp step of 0.2. I'm going to say 0.5. Our ramp clearance of 0.1. Radial ramp clearance is going to be 0.1. Helical ramp diameter, we're going to make that smaller. We're going to make that 0.125, which also makes our minimum ramp diameter the same. There's not a lot of room for this cutter to move in there. Now I'll select OK. Alright, so we have a helical move in the center, and then we spiral out. We do a couple rough cuts, and then we then do a couple finish cuts. Okay, so we have our pocket cleared, and now we're going to contour the outside with that same cutter. So we're going to go to 2D contour, and our feeds and speeds should come right back in from the last routine we just did with that end mill. Now we're going to go to the geometry tab, and the geometry we are going to select will be the bottom of the part edge. Now we're going to go to heights, and because we've milled the top down, our top height is going to be model top, and same thing with our stock, the model top. We're going to go to our selected contour, but we're going to go -0.01 so that we cut a little bit more material, so we're ensuring that we don't have any flash when we flip the part over to be machined. Okay, going on, the next tab is passes, 4,000. I'm going to put on wear cutter compensation, and we're going to go to roughing passes, and that'll bring up our finishing step over, and we're going to leave 0.01 as our finishing step over. 10 thousandths to be removed by the finishing cut. Okay, we're going to go move on down to maximum step over is going to be 0.4. Smoothing deviation, we can leave that at 4 thousandths. Actually, we're going to bump that up to 4/10. We're going to have one step over. Then we're going to go to multiple passes. We're going to do a maximum step of 0.5. finishing step down 1, and that, actually we're not going to do any finishing step downs, and our approach angle is a long wall. We're going to finish at final depth, and we're going to rough the final, and we're going to use even step overs. Minimize that. The rest of these parameters stay at default. And then we're going to select our smoothing, 4/10. Now we're moving on to the linking tab. We're going to leave all these at default. We're going to have a lead in of 50 thousandths, that's fine. Sweep angle of 90. Linear lead in distance of, we're going to do a linear lead in of 0.1. And we're going to have vertical radius of 0. We're going to have a lead in and out that is going to be both at the same angle or same length. And ramp we're just going to leave alone. And we're going to look at entry locations because we're cutting this out of rectangular stock. So over here on the corners we have a lot more material. So we most likely want to enter on one of these sides. And we're going to select the point that is, if we were to go to the top view, and then we were to roll the view vertically, we want it kind of in line with this hole here. So we'll do our lead in, our entry position there. We only have 25 thousandths of stock here and 25 thousandths of stock here. On the right and left it's saw cut, so we might have more. This ensures that our lead in and lead out is in a good place where there's not excess material. We're going to hit OK, and that puts our arc in and arc out right there up in the front. Okay, so moving on, we're going to move on to our chamfer. We want to chamfer this inside edge, especially before this circular groove is put in. So we're going to go to 2D chamfer, and we're going to select our chamfer, 1/4 inch chamfer tool from the Titan library, which is tool 15. We're going to go 4,000 RPM, 20 inches a minute's fine there, 20 inches a minute here, 20 inches a minute here, 10 on our plunge rates. We're going to geometry, and we're going to select the bottom of that chamfer, and we're going to select the bottom of the exterior chamfer. We want to make sure that our arrows are on the correct side of the part. They look like they are. If not, you can toggle them by clicking on them. We're going to go to heights. Okay, we're going to go from model top and model top because our stock has been machined down. Our bottom height is also going to be from model top. This allows us to project this profile to this height so it can calculate the chamfer height. We're going to go to the passes. Okay, 4/10 tolerance. We're going to do wear compensation. We're not going to have any finishing overlap. Our chamfer width is 0.01 and our chamfer offset of 0.04 at default's fine, and we're going to put 0 on our chamfer clearance. We don't need help with that. We're going to select the smoothing box, which is 4/10. Then we're going to go to the linking tab. We're going to leave these all at default. We're going to have a lead in with a horizontal radius of 0.1, and then we're going to have a lead in sweep angle of 90 is fine. A linear lead in distance is going to also be 0.1, and I guess it's going to be perpendicular. and we're not going to have a vertical lead-in radius, and we'll leave the entry positions alone and select OK. Okay, so we have our arc in, arc out for both of our chamfer mill routines. Now, so we're efficient with our tool change, we're going to go move on to drilling with that same tool. So we're going to select drill. We're still going to use that same drill bit, and our plunge feed rate and retract rate should be about 10 inches a minute with that cutter. We're going to go to geometry, and we're going to select faces. So we're going to select, why don't we select the 12 o'clock face, which is this chamfer here. We're going to leave, and then we're going to select the button that says same diameter. And provided optimize order is selected, it'll go in the shortest distance between the holes. Now we're going to go on to heights. Our retract height is going to be model top. So is our top height is going to be the top of the hole we selected. The bottom, we're going to actually set it at the hole top as well. And we have a 180 thousandths diameter chamfer right now there, so what we're going to put in is a negative offset of half of that, which is negative 0.09. And then we're going to go to cycles. And we're going to use a counterboring cycle that allows us to put a dwell in, and that dwell is going to be 1 second. So it's going to come in, go in, dwell for a second, pull out, and just in one peck. And this will ensure that the spindle rights itself, and the finish on the edge should be good. Let's hit OK. Alright, moving on. Next drilling cycle. Now we need to go in with the tap drill size. So we're going to go drill. We're going to select the tap drill that corresponds with a 1032 tap, and that is the 177 drill. Select that and hit OK, and we're going to select our 12 o'clock position again. So we're going to go 4,000 RPM, 16 inches a minute in 16 inches a minute. We're going to go to geometry. We're going to select our 12 o'clock position again. We're going to select same diameter, leaving the rest at default. We're going to go to heights. Again, model top. We actually don't want to do whole top on this because we want to include the chamfer. So we're going to go to model top, and the bottom is going to be the bottom of the modeled hole, but we're going to put the drill tip through that bottom to make sure that it goes full depth, leaves enough room for our tap. We're going to select cycle, and we're going to use a deep drilling cycle for this. Our peck depth is going to be 0.04, and our minimum peck depth will also be 0.04. We don't need the pecking depth reduction. That would be for if you're going to super deep holes. Okay, we're not going to dwell, so we're going to hit OK. So we've now done our tap drills. Now we need to come in and do our tapping cycle. And select drill. We're going to select the 1032 tap, which is this one here, tool 13. The description you see here isn't real that clear, but if you do select on it, you can see over on the right, this does say it's a 1032 UNC tap. We're going to select OK. And we're going to bump the RPM up to 700, but leave the surface speed alone. It's calculating for the number of threads per inch that it's required. We're going to go to geometry. We're going to select the same hole we've been selecting, and then we're going to select all of the same diameter. Okay, moving on, we go to heights. We're going to go model top. We are going to go from model top here as well. And then the bottom is going to be from model top and we need to calculate how deep we're going to go. So our print says that we're going to go 0.375, but we know the first 3 lead teeth on a tap don't form a full thread. So we're going to calculate what we need to do here. Select calculator. We know it's a 1032 tap. That means there's 32 threads in 1 inch. So if you take 1 inch, divide it by 32, and that's how much distance each thread needs. If we multiply that by 3, that gives us 3 thread pitches. It's almost 0.1, so I'm going to round that up to 0.1. So our finished thread depth is supposed to be 0.375 plus 0.1, or 100 thousandths, gives us a resultant of 0.475, or 475 thousandths. So we're going to put that number in here as a negative 475 thousandths as our distance. It looks like I put 470 inches. Let's make that 470 thousandths. Okay. All right. So now we go on to cycle. We're going to do a right hand tapping cycle, and we don't need it to well. Okay. And there's our tapping cycle. Moving on, the last routine we have is to make this this groove here, and we're going to use a Tuni Contour with a very small cutter, and there's not enough actual room for it to ramp in within there. The end mill itself is only 0.7 smaller in diameter than the finished size of the slot. So what we're going to do is we're going to do a rough and finish pass on this contour, and then we'll come back and just do a finish pass on this contour. Okay, so we're going to go to 2D Contour, and we're going to select tool number 5, which is our 16th and flat end mill. Okay, and we're going to bump the RPM up a little bit on this one, 5,000, because it's a small cutter. And we're going to do a cutting feed rate of 12 with a plunge rate of 6, or I'm sorry, a lead-in feed rate of 12, 12, 6, and 6 for our ramp and feed rate, plunge rate. The small cutters like this don't do too well in aluminum. They kind of want to gall, which is a term for when material re-welds or smashes into itself. It's malleable, and it often sticks to the small cutters. We're going to go to geometry, and we're going to leave everything. We're going to select this outside chain, and what we're going to do, how we're going to approach this, is it's going to do in effect 2 finish passes on this side, and that first cut will remove most of the material, and then we'll do a single finish pass on the inside, which will bring it to size. So we're going to select this chain first. Going to make sure our arrow is on the correct side of the blue line, which it appears to be. And then we're going to go to the heights tab. As you guessed, we're going to do model top and model top, and selected contours is our bottom. And we're going to go to the passes window. We're going to go climb cut, and in this case there isn't enough room to do a lead-in, and compensation requires a lead-in for the machine to do the compensation move. So what we're going to do is we're going to leave that at in computer, and for this one routine it's not going to output a G41, and that G41 is our cutter comp, so we won't be able to adjust at the machine the diameter of this cutter. We're going to move on. So all these radiuses we're going to leave alone. we're going to do multiple finished passes, and we're going to do 2 of them. And the step over is going to be 0.005. Okay, it's less than 7 thousandths or so we have in between it and the next wall. We're not going to do any lead ends. We're not going to repeat the finished pass. All these we're going to leave at default. We're not going to do any roughing passes. We are going to do multiple depths. And we're going to set this at 20 thousandths. And we're going to have one finishing step down at the bottom, and it's going to be 5 thousandths. We're going to leave our wall taper alone. Approach mode is going to be, we're going to change this because we're not leading in from the side, but our approach is going to be vertically. So we're going to plunge straight down with this cutter. And that's one reason I slowed the feed rates quite a bit down. We're not going to, in this case, finish at final depth. We're going to do a finish cut at every pass. And we're going to rough the final, and we're going to use even step downs. Okay, so now I'm going to we're going to select on smoothing. And then we're moving on to the next tab, under our linking tab. We're going to leave all these at default. We're going to deselect a lead-in entry and exit out. And we're not going to use a ramp either because we're going to plunge straight down. And then we'll hit OK. Alright, so we have our 2 finishing passes, which in effect is going to be a roughing pass for us. It'll do the first one and then move over to the second one. And now we have to do one more 2D contour on this edge, and that'll bring it to finish size. So we'll go 2D contour, and we're going to use the same tool, same parameters, so we can leave that alone. We're going to go to the geometry tab. This time we're going to select the inside curve, and we're going to leave that arrow where it is. And then we're going to go to our heights, changing both those to model top because our stock's been machined off the top. And then we're going to go to our passes. We're going to leave all this the same because we've already removed the bulk of the material. We are going to do multiple depths, and we're going to set our parameters for this as the same as last time. So 20 thousandths steps. We're going to have one finishing step down at the bottom, and that'll be 5 thousandths. And no wall taper, and we're going to come in vertically, and we're going to finish it at every depth. We're going to rough the final depth, and we'll use even step downs. And we'll minimize this now and select our smoothing on. Moving on to the next tab, we're going to leave all these at default, and we're going to remove the lead ends, and we're not going to have a ramp. We'll select OK, and that's our next routine. It's really just cleaning up probably about 3 thousandths, 2 to 3 thousandths off of this wall is being machined off by that routine. Well, our next operation is going to do the opposite side of this part. Now we're going to be holding this with a soft jaw, but if you remember, we're going to have a square piece of material about 1/4 inch thick still attached to the other side. We're going to set up our origin differently on this one, and it's going to also be a little bit different thinking on how we approach this. So let's create our new setup, and we're going to rotate the part in the orientation that we're actually going to be making it. Okay, and our stock right now size, we've machined the material off the top, and we still have our side offset of 0.025 for the rectangle, and our top offset should be 0.21, which brings us 40 thousandths less than the inch we started with. And then we're going to go back to, and our bottom offset's 0, it's sitting right on its machine face. And then we're going to go to the setup tab, and we are going to use we're going to select the Z-plane and X-axis. So our Z-plane is going to be here, and our X-axis is already oriented the way it should be. If you're having trouble with it, you may need to hit flip axis. Okay, but our origin, we're going to go to a model box point, and we're going to actually select this one in the center bottom. Okay, so our origin is going to be at the center of this puck, and this is the reason. We have a fixture that has a pocket cut in it that meets this diameter, and to find the location of how to register this part, it's easier to pick up on the diameter of the pocket, and it'll center itself within the fixture. We're also placing this at the bottom of the part. So we're going to approach setting up our tools differently. We're going to need to set our tools based off this being the bottom, and we'll go through that in the lab on how we approach that. So now that we have that set up, we're going to go and again use our convention, which I think this becomes 1022, and we're going to be operation 2, and we're going to use the work coordinate system 1, and we'll hit OK. Alright, so the material we need to remove is in between the top of here and the top of there. We could use a face mill, but this is a pretty small part to have a face mill rip across, and the larger the diameter of the cutter, the more torque goes on the part. And because we're really holding onto a circular profile, we can rip this part out by twisting it. So we're going to move down to, and we're going to do a 2D facing operation, but we're going to select tool number 2 for that one. So we're going to use the tool 2 from the Titan library, which is a 1/2 inch diameter end mill. And scale wise, you can see the size difference between it and the part. We're going to go up 4,000 RPM is fine, and we're going to do our 25 inches a minute we've been doing. And 12 or 13 is fine for the plunge rates. Actually, we're doing a face mill, so this would be 25. We're going to be approaching from off the work. On our geometry, we've got our stock box boundary, which is fine. Now we're going to move on to heights, and we're going to go from stock top's fine, and stock top is fine, and we are going to go to model top for our finished height. So we'll be removing the material between the cyan and the blue planes. Now we're going to go on to passes. We could change the pass direction, In fact, let's do that. We're going to go 90. And that should put us in the same axis as the fixed jaw of the vise. Pushing the force against it. Okay, our pass extension is going to be a little bit more than half the diameter of the cutter, half the radius of the cutter, so it's a 1/2 inch end mill. We'll put 0.3 is our pass extension, and we'll leave stock offset alone. And our step over, 0.4 would be optimum, but this is, so that's what we're going to put in. 0.4 is 80% engagement. We're going to go both ways, so it's going to crisscross back and forth. And we are going to do multiple depths because we're taking quite a bit off. We could take this off all in one pass, but if we want to ensure that we're not putting too much up force on our part, because we're not holding on to it very much, we're going to reduce that. So let's do this in let's do it in 0.125 steps, so 1/8 of an inch. And that's also going to go from both sides. And let's put in a finish step, and that finish feed rate can still be 25 inches a minute. And our step down will be 0.01 on that. And let's use even step downs. Okay, moving on to the next tab. Preserve rapid moves, stay down, distance, we'll leave all that alone. We don't need a vertical lead in, so we're going to leave that at 0. And the lead in and lead out will be the same. And let's select OK. So we've generated these passes that should mill down all of the rectangular material at the top, or on this top, and we're going to start, it looks like, back here and work our way back and forth. No, I guess we're starting here and it's climb cutting. Yeah, so it'll take a couple passes to remove that. All right, so let's simulate this. I don't think we've simulated it. So we'll go back up to setup 1 and simulate that one first. And we'll want to flip the orientation to where we're looking at the part in the same orientation. We're highlighting the setup. We're going to simulate. We're going to make sure stock is selected. And then we're going to hit play. We have our face mill, and we have our spiraling down. To one peck, we go spiraling down to the next depth. A little bit of a spiral. It's roughing the bottom, and then did a finish cut on the inside. This cut's going around the outside. Did a couple roughing cuts. Now it's doing its finish cut. Our chamfer mill comes in and does the ID and the OD. That would be inside diameter and outside diameter. Now it's going to come in and spot the holes. And then our peck drill comes in. I'm going to skip because I don't want to watch that. And then we have our tap coming in. And we have our 16th end mill doing its initial passes. And it's going to come in. And it's coming over and doing the inside because you see it change directions because we're climb cutting. Okay. Okay, so we're going to close the simulation on that side, and then we're going to go to setup 2, and we'll look at that one. So it should be taken off a little less than an eighth. And now we should be skimming it to do our finish cut. Okay. We're done with this part, and when you're finished with it, once approval, you can run. Again, you're going to need to upload 2 setup sheets, one for setup 1 and setup 2. And we'll see you on the next one.